In Java, we have three types of exceptions: checked exceptions, unchecked exceptions, also called runtime exceptions, and errors. A lot of people new to Java find this confusing, so let me make it super simple for you. Checked exceptions are exceptions that we developers should anticipate and handle properly. For example, let's say we want to read data from a file. What if the file doesn't exist? Maybe it got deleted just before we tried to open it for reading. Good developers always anticipate and handle these edge cases. So instead of letting the runtime terminate our program, we would better display a friendly message to the user saying, hey, that file doesn't exist. Now, the good news is that the Java compiler enforces us to handle these errors. That is why they're called checked exceptions, because they get checked at compile time. Let me show you. Let's create a new file reader for reading data from a file. So reader equals new file reader, let's say file.txt. Now look at this red underline. The Java compiler knows that the constructor of the file reader will throw an exception if the file doesn't exist. So it's telling us, hey, you haven't handled this exception, file not found exception. This is an example of a checked exception. So checked exceptions are exceptions that we should anticipate and recover from, and that is why they're called checked exceptions, because the Java compiler checks them at compile time. Now the second type of exception is called unchecked exception or runtime exception. As the name implies, these exceptions are not checked by the compiler at compile time. They occur because of programming errors. Null pointer exception is an example of a runtime exception. In the last video, we shouldn't have passed null to the sayHello method. This is a programming error. So unlike checked exceptions, we don't want to anticipate and recover by displaying a friendly message like, hey, we made a mistake and tried to use an object reference with the null value. Doesn't make sense. Instead, we should prevent exceptions like this from happening in the first place. How can we do that? By good coding practices and testing, a lot of testing, preferably automated testing. Now, that's a topic for an entirely different course. Now, other examples of runtime exceptions are arithmetic exception. This gets thrown if we try to divide a value by 0. We also have illegal argument exception for indicating that the argument we passed to a method was not accepted. Again, this is a programming mistake, not a kind of error that we should anticipate and validate. Another runtime exception you may see is the index out of bounds exception, which occurs if we try to access an element in an array or a string or a list using an invalid index. For example, we have 5 elements in an array, but we try to access the 10th element. Another popular runtime exception is illegal state exception, which gets thrown if we try to call a method, but the underlying object is not in the right state. So these are runtime exceptions. The third type of exception we have in Java is an error, which indicates an error external to our application. Examples are stack overflow error or out of memory error. So if the Java virtual machine runs out of memory, there's nothing we can do about it. So just like runtime exceptions, we should let the application crash rather than display a friendly message to the user. We should try to identify the source of these errors. These errors can happen because of programming errors, like an infinite recursion, or for reasons outside of our application, like a problem in the Java virtual machine itself. Next, we're going to look at the hierarchy of exception classes in Java.